Find the inverse of the matrix if possible. The reason why the question put if possible here, because you have to make sure the determinant you won't get a 0 with the square matrix you have. If your determinant is a 0, then there's no inverse, even you have the square matrix. So with a 2 by 2 square matrix and a 3 by 3 square matrix, how do we find the determinant number? If you have the matrix A with A, B, C, D, finding the determinant, we just simply to multiply AD to subtract BC. When you have a 3 by 3 matrix, finding the determinant, we are using the first row 3 number to treat that as a coefficient number, then multiply another matrix form. So let me show you the work. How do we do finding the determinant with a 3 by 3? So I use the number A, put a number A here, and then I draw the two vertical bar. When you have the matrix template come with a two vertical line, that means you are finding the determinant. With a matrix, you will see the big bracket here. Two line, that means is the determinant. So I write down the A, and then I use this for EFHI, have this 4 put into the first two vertical line here. Okay, now we move on to the next term. It has a minus sign. Now, on the second term, we go with the number B. Same way, you create a true vertical bar, and you are using this for D, F, G, I to F, G, I to fill in the blank in the determinant form here. The next term is a positive. And the pattern is positive, negative, positive, always, always. Now you go with the C. So the C multiply with, let me change the color here. So you draw the line, cut down a horizontal line and a vertical line, treat the C as an intersection point here. Now you are using this bar. So D, E, G, and I. Okay, now the next step, you just process by using the same way when you have a 2 by 2 matrix, when you find the determinant. So this one, you have the EI to minus FH minus B multiply DI to minus FG plus C to multiply DI to minus EG. And then the next step, you just process the calculation until you get a single number. Again, as long as the number is not equal to 0, then you will have the inverse. When the number is a 0, and there's a typo here. When the number is equal to 0, that means no inverse, even you have the square matrix. Determinant number could be a positive number, could be a negative number, could be a fraction, could be a decimal. As long as it's not a 0, then that means you will have the inverse.